Hey guys, welcome back to this video. Today we'll be differentiating e, ln, the natural log, and y. I just want to say that at first these things can seem difficult, but they're really not when you get into them and you know what's happening. So I'm just gonna get into what happens when you differentiate these. So let's start with e. Let's give e a power, 3x, and then let's give x a power as well, cubed. And then when we differentiate this, I'm going to tell you exactly what's going to happen. We take this power of e, we differentiate that, and that differentiation becomes the what's it called? The front. Well, I've forgotten the word. The coefficient. That's what it is. The coefficient of e. So let's do that. Let's differentiate 3x cubed, which is 9x squared, multiplied by e, and then the power does not change, and that's all that happens. See, it's quite simple, really. Yeah, if there was no power here, there would be no x at the front. So all you have to do is just differentiate the power. That's literally it, and then just put it at the front, and then don't change any of this. Just add bits on with e. Now that's pretty much e. ln's a bit stranger, but that's just logs for you. Let's do it. So let's give ln let's say 2x. Now this differentiated, what you do is you take what's in the bracket and you put it under 1. So 1 over what's in the bracket, so that's 2x, and then you multiply it by what's in the differentiation of what's in the bracket. So you just multiply it by 2, because 2x differentiated is 2, and that becomes 1 over x, since the 2's cancel here. Now I'm going to do another example to show you another part of natural logs. Let's do 2x squared. Now if you were to do a power, what logs tell us is that there's actually, if you have a power in here, it actually just comes to the front and is multiplied by it. So this would become 2 multiplied by 1 over 2x multiplied by 2, which is equal to, one of the 2's cancel, so you just have 2 over x that's left. Hope that's not messy enough. Can you see it? There you go. And then for y is a bit funny. If we were to have like y to the power 5, this differentiated would be normal 5y 4 multiplied, though this is the bit that's different, multiplied by dy dx, because that's just the rules, you know. And also like things like if you want well, I'll do that in another video. There's like you need to use this a lot in implicit differentiation, which is when an equation has both x and y properties, not just explicitly where y is on its own. So this is where you need to learn this, definitely, because implicit differentiation is just a whole nother topic. Basically, this is how you differentiate these weird letters. You don't really differentiate at all in like AS. So this is how you do them. They're quite easy. Find some questions online if you want to practice them. If not, you can just make up some and try them out. And if you have any problems, just comment below and I'll help you. Yeah, that's pretty much it. I'm gonna do a video on implicit differentiation as well, so we can go over differentiating y a lot more, and there'll be like x squared and y y5, y to the power 5, and it gets a bit more, you know, has a bit more rules in it. So anyway, bye guys, that's everything.